Hello, this short video shows how Mako, the digital document SDK from Global Graphics, solves the problem of dividing a PDF into smaller files. Let's start with the definition of the problem. Sometimes there are times when the sheer number of pages in a job makes it unwieldy. What's needed is an easy way to split the job into smaller ones. For this print service provider, a command line app will fit nicely into their workflow. It can be created for Windows, Mac OS or Linux using the same code. The app will make use of multi-threading to speed up the output. Such code is often platform-specific, although the Mako SDK itself is cross-platform. Mako ensures that the resources required for the pages being output are present in the PDF. For example, the source file may contain a font used on many pages, so when those pages are split between different files, the font must be included. The screen grab shows the app in action, but let's take a look at a live demo. So let's take a look at the application in action. I've got a compiled version of it here, makosplitter.exe, and there's a single supporting DLL that's needed that writes out the actual PDF. I've got a test file. This test file was actually created using Mako. It consists of 1,000 pages. They're very simple pages, as you can see. So we'll use that to demonstrate what's going on. Over on the right hand side, I've got a PowerShell window open at exactly the same place. So let's run the utility and see what happens. Give it the name and let's ask for files of 100 pages each. So hit return on that. And instantly the files are written. So if I take a look at one of these, you can see this is page 701. If I go to the end, page 800. So you can see those are written very quickly, and they're written in parallel due to the multi-threading. Let's stress it a little bit more by doing the same command again, but this time requesting PDFs with 10 pages in them, and you can see they're now being written to the folder. So if I look at the last one, there's my last 10 pages. So that's it, a very simple command line utility that will take a source PDF and split it down into separate PDFs with a number of pages that you can choose. On the right are extracts of the actual code. The Mako Document Object Model, or DOM, expresses a hierarchy of objects, the root of which is an iDocument assembly. Below this are one or more iDocuments, although for PDF there is only ever one. iDocuments contain, not surprisingly, iPages. iPages contain the objects that describe the page, text, images, vector graphics, and these in turn will reference shared resources such as font and color definitions. Mako is designed to hide this complexity, so when the reference to a page is copied from one document to another, any resources that it requires are also transferred if they are not already present in the target document. The dump chunks method is responsible for actually writing out the separate PDFs. A chunk is the range of pages from the source document that must be copied to the target split PDF. The method begins by creating an array of jobs. The code to do this is not shown here, but it simply iterates through the source document, creating a new job for each chunk. References to the pages that need to be copied for a given split, say pages 1 to 10, 11 to 20, 21 to 30, and so on, are added to the array cloned pages for a given job. When this process is finished, there is a job defined for every split PDF. Processing of each job now takes place, each on its own thread. To use the available threads, the method threadRunner is called to process a job, and this in turn calls another method writeChunk that creates a new iDocument assembly and iDocument to which the correct range of pages from the source document are added, and the job for that split PDF is complete. Note that Mako only copies the page content when the file is finally output. Mako uses a system of smart pointers and a strategy of fetching content into memory only when necessary, caching to avoid unnecessary disk reads, and releasing memory, file handles, etc. as soon as they're no longer required. Thus, Mako is suitable for devices with limited CPU and RAM resources, such as mobile devices, Windows IoT, or even embedded controller boards. That completes our look at the code and actually brings this video to a close. I hope you enjoyed it. Look for other Mako videos on the Global Graphics YouTube channel.